All right, so as of right now, our idea of having to find this sum would be to plug every single thing in and add them all up. So right now, if you remember, and this is a big thing from section 8.1 that we kind of ended 8.1 with, but we said this is a summation symbol, summation notation. This right here is a question, okay? This is asking you to find something. It's actually asking you to find what this equals. It's asking you what number it's equal to. The way that we would do this is we're basically saying from term number 1 to term number 20 being plugged all into this thing right here, what would they all add up to? Now, right now, this would be a very, very long drawn out process. We would do 3 times 1 plus 7 plus 3 times 2 plus 7 plus 3 times 3 plus 7 plus so on and so on until we get to 3 times 20 plus 7. We would have to do a lot of work. That's a lot of stuff going on. That's a lot of stuff that we don't want to have to do because there has to be a better way to do it. Okay. The nice thing about these is if they're arithmetic sequences or series, which you should be able to tell that this thing is arithmetic because it is a number times something plus something. This is linear, right? Y equals mx plus b. It's an mx plus b. This is arithmetic. Since it's arithmetic, we're allowed to use a formula. That formula looks like this, and it's given by S. It's given by Sn. So the S stands for sum. I'm going to try to erase some of this. This is still 8.2. So the sum of this is going to be Sn is equal to. Now, this is saying S of your numbers, whatever. So in this case, N would be 20 because that's what you're going up to. And then it would be N times A1 plus AN over 2. Okay, and I'll run through that example on the left. But what we're going to do is instead of having to find every single one of the terms from term 1 to term 20, we just have to find term 1 and we have to find term 20. That's what we have to do. Okay, so this is the formula. This is the one that you're going to have to use. And again, I think I'm going to give you those ones. But again, if you don't know what you're doing with them, it's not going to help you. Having the formula is only half the battle. Knowing how to use the formula is the other half. It's obviously more important. Okay, so if I want to find the sum of the first 20 numbers, I'm going to use S20 because that's what I'm plugging in for N. Equals 20 is the number that gets plugged in times, and then I have to find what A1 and A20 is. Okay. So I will have to go in here and I will have to do a little work, but I'm only going to have to do it twice instead of having to do it 20 times. So I still have to find what A1 is. So what I'm going to do is I'm going to plug 1 into this equation. So 3 times 1 plus 7 is equal to 10. And I'm still going to have to plug the last term in, which is 20, into my equation. So 3 times 20 plus 7, which is 67. So I now know my first term and I know my last term. Okay, so now it gets plugged into my formula. A1 is 10. A20, the last term, is 77 or 67. All over 2. And now this is something that your calculator is able to handle, right? So this is saying the same thing as 20 times 10 plus 67 divided by 2, I think is 38.5. Then what number is that? 770? Yeah, 770. So the sum of all of those numbers added together is going to be 770. Now that cuts out an enormous amount of work for you, right? That makes it so you do not have to plug in 20 numbers. Is it possible to plug in 20 numbers? Absolutely. Is it something that we are going to want to do? No. All right. So just kind of keep that in mind. Understand that that's exactly what we're supposed to be doing here. All right. Now, something that you have to be kind of smart about is if we're asked the question like how many terms there are in one of these things, you have to make sure you pay attention to what the starting term is and what the ending term is. Because if I started at 3 and I ended at 7, the number of terms that I'm not plugging in is not is not 7. So if I say that I start from I equals 3 to 7 of 2n plus 5 or 2i plus 5 would probably be. if I start with something like this and I ask you to find the sum of this, I'm not plugging in 7 terms to this, right? I'm starting with 3, then 4, then 5, then 6, then 7. I'm plugging in 5 terms here. Okay, so you have to be kind of smart with that. What's up, Zach? I'll have to try that out some other time because that's going to take too long to go through. But yeah, I think that it works okay. I don't know. So there might just be something in there. Maybe you added an extra number. I don't know. Yeah, but every example that I've done works out okay. So I'm going to give you guys one. I want you to try one. So again, this is just something to kind of think about. Make sure that you're thinking about these ideas, which one you start with, which one you end with, because those are going to change your first term and your last term. So let's go through one that you're probably likely to see on your big ideas thing. Let's say that we've got the summation of I equals 1 to 10 of 9i. So this would be one that's similar to what you would see on your big ideas stuff. I equals 1 to 10 of 9i. All right, so let's walk through it. And again, here's the notation that you're going to see. This is equal to the sum of the numbers, which in this case is 10, equals, there are 10 numbers in this term, times A1, which we have to find A1. A1 is going to be the same thing as 9 times 1, which is 9. We also are going to have to find the last term, which is A10, which is 9 times 10, which is 99. So this is going to be 9 with what? 90. I'm doing the math in my head while we go. So 90. So 9 plus 90 over 2. And then so now this is going to be the same thing as 99 over 2, which is what? 44 and a half times 10 is going to be 445. 49 and a half, so 495. Nice job, guys. Let's go. So 9 plus 99 is 49 and a half. And then you multiply that by 10 to get 495. Now, this is a lot easier than having to plug all of these in by hand. Now, is that possible for you to plug them in by hand? Absolutely. I'm not taking that away from you. I'm not saying that that is something that you can't do. Just keep in mind that this is a clear-cut, every single time should work way for you guys to be able to add these numbers up. It only works with arithmetic sequences in series, though. So if you have something that is like 2 to the n power, that is not the same thing as an arithmetic sequence. Okay, so if you have 6 to the 7th or 6 to the 7n power or 7 to the 2n power or anything that looks weird, n squared, n to the 5th, anything like that, it will not work for arithmetic sequences in series. Okay, it has to be arithmetic, which means that it has to be linear, and you have to be able to see how the pattern grows by a certain amount each time. Now, one thing that Sean was saying over here while you guys were working on this was, Sean is recognizing that you can type this into your calculator as a y equals. So he did y equals 9x, and then that would give him every one of his terms. The first term, 1, would be the x value. So 1 comma 9, 2 comma 18, 3 comma 27. It would give him every one of those terms. So actually, he took all of the math and having to solve all of this out right with his calculator. Now, there's one thing to just be kind of leery of. If your calculator goes away, you can't use it on the SAT. I give you a no calculator portion on the math, which I'm not going to. But if you have something that looks like that, you're not going to be able to use your calculator. Just understand how to plug those numbers back in. It just saves you some time now. Okay? Any questions on finding the sum of an arithmetic series at all? Questions, issues, or concerns that you guys can think of? Not right now. No, that's going to be way later. Yeah, that's going to be way later. Yes.
So are you like telling me like what's in between the terms of the exact middle?
So you're counting the average from the first term to the last term, basically, yeah.
Oh,
So you're counting that and then multiply, because if you have a distance between here and here and here and here and here and here, they're all going to meet in the middle.
yeah.
And then you just multiply that middle term by how many you have for the in the pattern. How many questions are in the pattern? So you're basically finding the average of the first term and the last term, because they're all going to converge to the middle, and then multiplying it by 10 because there's 10 terms that are going to converge to the middle.
Alright.
Yep. Yeah. How many there are? Yep, and it's the number of terms in the sequence. Yep. Yep. All right. So now we're going to get into 8.3. And this is a new section that is using the same kind of ideas as what we did just a little bit ago, but it's going to be a different style of sequence. Okay, so it's not going to be an arithmetic sequence. It's actually called a geometric sequence, which is going to have the same kind of identifiers that that the other ones did. Okay, so it's going to be you're going to be able to see a constant. You're going to be able to see something happening every single time. And it should be very obvious to you. Okay, so this is a geometric sequence and series. But it's going to have the same kind of idea that we had before. Yeah, Joe? You're good? Yeah. Okay. All right, so 8.3 is about the geometric sequences and series. Now I'm going to show you two patterns of things that could show up to be geometric. Okay, so let's say that we have something like 6, 12, 24, 48, 96, and so on. So if we have something that looks like this, now you have to start thinking. Because arithmetic sequences in series the entire time would be very, very clear cut and easy, because what we're doing is adding a certain number every single time. This is a little tiny bit different because we're not adding a number every single time. What are we doing every single time? Multiplying. So this should still be a very easy identifier. The last one should have been easy because you could say I'm going up 3, up 3, up 3, up 3, up 3. This one we're not. We're multiplying by 2. So multiplying by 2, multiplying by 2, multiplying by 2. Every single one of those we're multiplying by 2. Okay. Now that is the number that we're going to be paying attention to, because your formula for this is going to have something with an AN, something with an A1, and something with an R. This number is R. So that is your R value. Okay. So that's what you have to kind of think about. That's the number that you're going to have to find. That's like D in yesterday's lesson. Okay, so yesterday's lesson, you remember how we found the common difference? This is called the common ratio. Okay, now one thing that I want you to kind of think about with this is there are some times where you're going to look at this and you're going to say, oh, I'm dividing by a number. Okay, so you're going to say, like, I'm taking a number and dividing it by something every single time. Don't ever think about division in this problem, in this set of problems. Okay, so like this example right here, where if I start out with 256, 64, 16, 4, 1, so on. Everyone could recognize that it looks like I'm multiplying by 4, or I'm sorry, dividing by 4 every time, right? So I'm taking a number, dividing by 4, dividing by 4, dividing by 4, dividing by 4. That's true, but I don't want that to be my common ratio. I need to keep things in terms of multiplication because it's going to make my life way easier. So if I don't want to divide by 4, what can I multiply by? Multiply by 1/4, right? So instead of dividing by 4, I'm looking at this being a multiply by 1/4 every single time. And you can hopefully see I'm still multiplying. So my common ratio, my R value in this one would be 1/4. My R value in this one would be 2. You can also see how this is always going to be a nice pattern. You're always going to be able to see in these last two sections that it's either added every time or subtracted every time, I should say, or I could say. And then this one is going to be multiplied every single time. Okay. So let's go through a couple of examples so we can see what it looks like in use. You guys can hopefully see how to use it. But then again, there are going to be a lot of the same things that we talked about yesterday, where there's different ways to produce the equation. Okay. I could give you A1 and the ratio. I could give you a different term in the ratio. I could give you A1 and a different term. I could do a whole bunch of different things and still make you find the pattern for the sequence. In order to find the pattern for the sequence, it is AN equals A1 times R to the n minus 1 power. To the n minus 1. And that n minus 1 is only attached to the R. So I guess if I want to, maybe put a little dot right here so that you know that the A1 and the R to the n minus 1 are not the same. Okay, so it is not n minus one being raised to everything. That n minus one is only being put on the r. Now, obviously, same exact things as last time. An is still like your y value. N is still like your x value. R is the ratio that we just talked about, and A1 is your first term. Okay, so you can see a lot of this stuff is overlapping from the stuff that we did yesterday. All right, so let's say we have a first pattern. Let's find one of these patterns so that we can see what it looks like. So we've got 5, 15, 45, and so on. Now, hopefully you can see what's going on here. You can see what the pattern is. After even 2, you should be able to see what the pattern is for this. You should be able to take your first term times something gives you your second term. Your second term times the exact same thing gives you your third term. If that happens, you've confirmed what the rate is. So what is the ratio for this? The ratio is 3. So I need R and I need A1. Do I have A1? What is it? 5. Okay, so now if I'm plugging this into my formula, I get AN equals 5 times R is 3 to the n minus 1. Now, please do not simplify this. This is different than 15 to the n minus 1 power. I'm telling you right now, on Friday, people will give me the answer of 15 to the n minus 1. Don't let that be you, because I will mark it wrong every single time. Okay? Even if you have this written right above it, and then you make the step and you say, oh, this is 15 to the n minus 1. Usually, if you have the right answer, and then you do one extra step, I usually only take a half a point off. I am going to take a full point off if you do this. Okay? This is not correct. You can't simplify it. It's not the same thing. This number is not 3. It's not. This number is not 3. It's 3 to a power. It's 3 to the second, or 3 to the third, or 3 to the 0, or 3 to the negative 1. It is not 3. So you can't say 5 times 3 because this is not 3. All right? So just be really careful on that, because that's a problem that people run into every single time on this test. In all honesty, this quiz is not that challenging, because it's a lot of, simple arithmetic, multiplying, adding the same number every single time, plugging numbers into an equation, solving the equation, and moving on with it. It's a lot like an Algebra 1 test. But that means that people are going to forget the rules that they're remembered in Algebra 1, which is one of these. Don't do this. Okay? Don't lose points on that because you don't know that you can't simplify. Make a note of that. Make something happen with that, so you know for a fact, I'm not going to make that mistake. Okay? I'm going to give you guys one of these, and I want you to try to apply what you know from yesterday to figure out how to write an equation. A lot of you are going to be able to make this connection between yesterday and today because it's the same kind of idea. We're just going to, I want you to kind of run through it to see if you can find what your A1 term is and so on. All right, so let's say that we have a first term of A4 is equal to 12, and the ratio is 2. I want you to find an equation for AN, okay? Same kind of idea as yesterday, it's just a different equation. So give it a shot, see what you can come up with. We'll work through it together if you can't figure it out, but I want you to at least try it on your own to see if you can figure it out. All right, so remember we have AN is our formula. So AN is equal to A1 times R to the n minus 1. I know what R is, so I can plug that in. I know what AN is, so I can plug that in. I know, oops, circle. I know what AN is, so I can plug that in. And I know what N is, so I can plug that in. I know that looks crazy, but hopefully that makes sense when you guys are looking and plugging things in. So I've come up with an equation now that's going to be 12 equals A1 times R is 2, N is 4, minus 1. So now this is saying the same thing as 12 equals A1 times 2 to the third, which is the same thing as 12 equals A1 times 8, divide by 8, divide by 8, you get 1.5 equals A1. And remember, what you needed to solve this problem was what is A1, what is R. I have R, I have A1, now I can make my equation. So if I have both A1 and R, it is going to end up being AN is equal to A1, which is 1.5, times R is 2 to to the n minus 1.
Wait, what?
Gotta give me more than that.
Oh, okay. Wait, why are you leaving the 4 and the 10?
I don't know what you're saying. Why am I not leaving what 4 and what n?
The 4 and the end, like where you have 4. Oh, because that's what the yep, I got it.
Yeah, this is allowing you to solve for a1.
Yeah.
Okay, I'm gonna leave you guys with one more problem. We're gonna do the same kind of thing that we did today. Tomorrow, where I'm gonna go through the way that you can find the sum of the geometric sequence, which should take like 5 minutes. And then we'll talk about, or and then I'll give you guys time to review your stuff. But let's say we have A2 is equal to 12 and A5 equals negative 768. Okay, so now this is a little bit more challenging. Huh? That's what you guys get. And then I want you to try and solve this the same kind of way that we did it yesterday. Okay, so try to solve this the same exact way that we did it yesterday. And then in about 2 minutes, I will start working through it so that we can hopefully leave off with a finished example. So I'm going to set up 2 equations. I'm going to set up one equation using the A2 part, and I'm going to set up another equation using the A5 part. So I know that they're both going to go into the equation an equals a1 times r to the n minus 1. I'm going to have 2 unknowns here. One unknown is going to be right here, and one unknown is going to be right here. Everything else should be able to be plugged in. So for the first one, an is 12. A1 I don't know, r I don't know, but I do know that this is going to be 2 minus 1. On the other side, negative 768 is equal to a1 times r times 5 minus 1. Now again, there's one step of simplification to make at this point. So there's one step of simplification to make right here. So it's going to be 12 equals a1 times r. And then this one is going to be negative 768 equals a1 times r to the 4th power. Now, if you remember way back to when we talked about exponential equations, I actually talked to you about how to solve these things. This one, what I would do is I would always solve or use the equation with the smaller r value first. Okay, I would always use the smaller r value first, and I would always solve for a1. Okay, in this, a note that I would make is I would always solve for a1. Okay, I would use substitution on this more than I would use elimination. And I would always use the one that has the smaller r power. So this is the one that I'm going to simplify, and I'm going to solve for that by dividing by r on both sides. So I get a1 equals 12 over r. Now I'm going to plug that into my other equation. So I'm going to get negative 768 is equal to 12 over r times r to the 4th. And the reason that I always use the smaller r is because now I'm able to cancel one of these r's together. Okay, so this is going to end up being r to the 4th will become r to the 3rd. This one will go away. So I'm left with negative 768 is equal to r to the 3rd power. And now I've got something I can solve for r. Oh, sorry, 12. Sorry, yeah, I should have 12 there. Okay, and we'll go through another example of this a little bit more tomorrow. Okay, so now I have negative 768 equals 12r to the 3rd. In order to solve this, I'm going to divide by 12. And what is negative 768 divided by 12? You know? Negative 64 equals r to the 3rd power. So I'm going to cube root. So I'm going to get r equals negative 4. And then it would be really nice because I can just plug this number into here, and I get 12 divided by negative 4 is negative 3. So a1 is negative 3. Okay. If you have questions, let me know. Big Ideas is due tomorrow at 8 a.m.